Good evening. This is Mr. Brzezinski. This is 9.7 special right triangles. We're breaking it up into 2 days. We'll do 30, 60, 90 triangles on today, and then the next video will be 45, 45, 90s. So let's start with a joke. What do you have to know to get top grades in our geometry class? All the angles. Uh, Okay, moving on. So we're going to derive where the 30, 60, 90 comes from, and then we're going to superimpose it over there. So 30, 60, 90, if we start with an equilateral triangle, let's draw an L through the base. So we know, first off, all of this is congruent. Okay, let's draw an altitude to the base, causing 90 degrees. Well, if it's equilateral to begin with, each angle had to start at 60. If an altitude drawn to the base, it's also an angle bisector causing 30. So technically we just created two 30, 60, 90 triangles inside of this figure. Okay, but the two triangles are similar. Done. What is each angle measure? Done. Figured it all out. Now let one side be a length of 2x. So if this is 2x, this is 2x, this whole bottom piece is also 2x. Meaning this was also a median, so x and x. Well, we learned prior to this a formula. If we had a right triangle, it was called the Pythagorean theorem. So looking at this right triangle beforehand, we know that 2x squared, put in parentheses, is equal to, we'll call this h. That's what we want to find the missing side. H squared plus the base, which is x squared. We're solving for h. Well, 2x squared is 4x squared equaling h squared plus x squared minus x squared over. This is 3x squared equaling h squared. Still haven't gotten h, square root it. So if we take the square root of 3 is still 3. The square root of x squared is x. And I'm going to put that in front, which is now h. So now knowing this, we know that the relationship in a 30, 60, 90 right triangle, the across from the 90 is what? The 2x. Across from the 30, boop, is the x. Across from the 60 is x root 3. This is what needs to be memorized. So you need to know that a 30, 60, 90 triangle, the sides that match up are x, x root 3, and 2x. They gradually get bigger as you go. X is the smallest, x root 3 is a little bigger, 2x is even bigger than that. So hopefully that will make sense to you. So we're going to use that to superimpose over. So what do I mean? Example 1. Find all the missing side lengths. Note, start by superimposing the relationship. So we see this. This is a 30, 60, 90. So this is the x. This is the x root 3. This is the 2x. Well, which side do you have? Oh, you have the 18, which is the same as 2x. So we'll set 2x equal to 18. X ends up equaling 9. Alright, so that means this side over here is 9. This side over here, you plug in the 9 for x, 9 root 3. Done. Moving on. Another 30, 60, 90. Superimpose. Across from 30 is x. 60 is x root 3. Across from the 90 is 2x. So this time we have x root 3 is set equal to the 12. Divide by root 3. Now here's why we learn this. Are we allowed to leave the root 3 in the denominator? Absolutely not. So what do? You multiply top and bottom by root 3, and you get 12 root 3 over 3, and now you have to decide, does the 3 go into the 12? And it does, giving you 4 roots of 3. That's equal to x. So this side here is 4 root 3. This side over here, you had 2 times 4 root 3, giving you 8 root 3. Good stuff. How we doing? Okay. Number 3. Same thing, we got 30, 60, 90. So we got cross from the 30 is x, cross from the 60 x root 3, cross from the 90 2x. So this time we have the x side, which is 5 root 7. So what do? The easy side is over here. We have 2 times that, so then that's 2 times 5 root 7. So you can see that that's 10 roots of 7. And over here you have 5 root 7 times root 3. Well, the roots with roots, numbers with numbers, so we end up with 5 root 21, and that does not break down. Alright, moving on, number 4, 30, 60, 90, superimpose it, x root 3, 2x. So we have 5 root 6 equal to the 2x. Divide by 2. Our x side over here is 5 root 6 over 2. This side over here, you're going to be multiplying by root 3. So we got 5 root 6 over 2 times root 3. So the top becomes 5 root 18 over 2. But wait, root 18 breaks up into root 9 and 2. So we really get 5 times 3 root 2 over 2, which ends up being a grand total of 15 root 2 over 2. See, good thing we learned how to simplify these things. All right. Continuing on, find the missing sides. So we've got to plug it in. Cross from 30 is x, 60 is x root 3, cross from the 90 is 2x. So once again, we got the x root 3 equaling to 7. Divide by root 3. Can't leave it in the bottom, so we multiply top and bottom by root 3. 7 root 3 over 3. And we know that's equal to the x side, so that goes here. For the 90 side, multiply that by 2, and we get 14 root 3 over 3 for this side here. Alright. Try the next one on your own. If you did so, you probably thought this was 2x. But wait a second, I don't have any of these things marked. I don't know anything about this triangle. So this triangle is impossible. There's not enough information. Tricked you. Made you do that on your own and it didn't work. Moving on, find the perimeter of an equilateral triangle. So we'll draw an equilateral triangle. Okay, with an altitude of 8. What did we learn from the beginning? Scroll back if you need to. We learned that this breaks up into a 30, 60, 90 triangle. So while doing that, we want the perimeter, so we need each side length. So we're looking at this across from the 60. Let me change colors, superimposing. Here's x, here's 2x. This means this is x root 3 for this side. So, we said x root 3 equal to 8. Divide by root 3's. Can't leave it in the denominator, so we multiply top and bottom by root 3. We get 8 root 3 over 3. 3 does not go into 8. So that's this halvesy right here. We want the whole thing. So we're going to multiply by 2. So our final answer for one side length is 16 root 3 over 3. But wait, we have 3 of these, so we times it by 3. And look at that, the 3's cancel out, so our perimeter is equal to 16 root 3. And then there's some type of units there. Finishing it up here, we have a trapezoid. We want to find the perimeter, even though it doesn't say that. So let's figure out the perimeter. So we could draw on a rectangle. It's not isosceles because the 4 and the 6 are not the same. But at least over here, what we can tell is that this is a 30, 60, 90. So once again, superimposing. This would be the x root 3 side. This would be the 2x. So this makes this the x. So going off of that, we know that the 2x is equal to 4. So x equals 2. So this piece down here is a length of 2. This side is 2 root 3. Well, from here to here is the same as up there, so that's 10. And now we don't know anything about here, but we do know it's a right triangle. But wait, if this length is 2 root 3, this length is 2 root 3. And still we do not have any type of numbers there, but what do we know? That if we have two sides to a triangle, and it's right, we could use Pythagorean theorem. So we have 6 squared is equal to, in parentheses, 2 root 3 squared plus x squared over here. Figuring it out, we have 36 is equal to squaring this. That's 2 squared and root 3 squared. So that's 4 times 3, which is 12, if you didn't figure that out, which you did. You guys are smart. Subtract the 12 over 24 is equal to x squared, root it, and you get in 4 and 6. So you really get 2 root 6. Find the perimeter. So the perimeter is equal to the 4 plus the 10 plus the 6 plus the 10 plus the 2. So you add it all up, 10, 20, 32, plus this side here, which is 2 root 6. And you can't combine the 32 and the 2 because this has a root 6 on it and the other one doesn't. Leave it. And for number 9, the last one. This one's my favorite. To challenge. So what do we know? This angle up here is being bisected. It's also the big triangle. So this angle up here, this large angle, is 60. Okay. Our goal is to find the perimeter of ABC. Well, I look at it and right now, I am stuck. Okay. If yours doesn't say so, this piece right here should be written in as a 6. I'm pretty sure we corrected that, but if we print out the wrong one, then please put that in. So you need that information. So knowing that, we look at it. So the big triangle is a 30, 60, 90, but we don't know where to move from there. But what you do notice is that this triangle, let me highlight it here, all right, 30, 30, because it's bisected, so it's these two sides are congruent. So this side is also 6. Okay. Does that make sense to you a little bit? Which then helps, because then what do you notice about this triangle here? Well, if this angle's 30 and that's 90, we have this triangle of 30, 60, 90, and this side 6. So we can set 2x equal to 6, so x equals 3. Meaning that this spot right here now is 3. Meaning this spot across from it, because this is 60, is x root 3, which is 3 roots of 3. Now look at the very large triangle that we're looking at, where this side is 3 root 3, and this side down here is 9. We want this side over here. Alright, this side over here. So we can look at it, if that's 3 root 3, this is twice as big, because this is the 2x side, if this is the x side. So then this side is 6 root 3 in the large one. So then what's our perimeter of the whole thing? We'll add it up. 3 root 3 plus 6 root 3, that's 9 root 3. And then we have a 9, which can't be combined with that. Some type of units, lock it in, and we're done. Hopefully that went well for you, and we'll see you tomorrow. Ta-ta for now.